Hello, my name is Andre Bato, and my presentation is on RSA encryption, or just the RSA algorithm that we went over, or that we read over in chapter 4 in our textbook. Um, so, my presentation overview is that first I will talk about cryptology versus cryptography, what is RSA encryption, decryption, and RSA as a public key system. I will also talk about how it generally works, what is the math involved, and then I will also show you guys some of the snippets of my C++ code for it, which is just a simple implementation of the RSA algorithm to show how it works exactly. So first of all, cryptology versus cryptography. Cryptography is the study of conversion of plain text, readable format, to ciphertext, which is the non-readable format encryption. It is also called the study of encryption. Cryptology, on the other hand, is the study of the conversion of plain text to ciphertext and vice versa. It is also called the study of encryption and decryption. And just big main points of the two is that cryptography, it takes place on the sender side, while cryptology, it takes place on the sender and the receiver side. So it can be both. So as you can see here from the this picture that I provided, you can see that cryptography turns from plain text to ciphertext only. Cryptanalysis is ciphertext to plain text, while cryptology encompasses all of those. So it shows here that cryptology is the parent of that whole study. So next, an RSA overview. So it's used by modern computers to encrypt and decrypt messages. It's asymmetric, which means that there are two different keys. It's also a public key cryptology, which means that one of the keys can be given to anyone because that one is public, while the other key is private. And then ultimately, the algorithm is based on the fact of that finding the factors of a large composite number is difficult when the factors are prime numbers. The problem is called prime factorization. It's also called key pair, like I said before, public and private key. So just to show you what, or just to gloss over what public key and a private key is that the private key is the one that needs to be kept secret, obviously, because it's private, but it's the one, public key is the one that is known by everyone, which is used to encrypt the message, and then that's what the private is to decrypt it. Um, so just a little bit more on the RSA um, algorithm is the one-way function that is easy to compute. Finding the function that reverses it or computing it is the function that is very difficult. So RSA uses a concept called discrete logarithm. This works such as that normal logarithm. The difference is that the whole number are used in, and in general, a modulus operation is involved. So an example is a to the power of x equals b modulo n. This discrete logarithm is about finding the smallest x that satisfies the equation, and when a b and n are provided. So what it's used for a lot of security and communications on the internet. It's also instrumental for e-commerce. It's used for the transactions uh, over the internet to safeguard sensitive data, such as maybe credit card numbers or bank account info. And then a little bit of a history of the RSA encryption is that three colleagues, they were researchers slash professors at the time at MIT. They were Ron Rivas, Adi Shamir, and Leonard Adelman, and that's why it's called RSA, because they just put their last names, Rivas, Shamir, and Adel, in 1977. But originally, they got the idea from a year before by with the group Whitfield Diffie, Martin Hellman, and Ralph Merkle in 1976. That's where it originally came from. They like the research, so what they did was they wanted to improve on it, and what they did was that unlike previous methods requiring securely exchange keys to encrypt and decrypt messages, RSA provided a method for encryption and decryption without both parties needing a shared secret key. And then RSA could also mark messages with digital signatures and allowed originators to create messages intelligible only to intended recipients, so third parties couldn't decipher them. So here's a little overview of the RSA. So you have the sender, which has the plain text and has the public key. So it has the RSA and cipher. Then it goes into a communication channel with the ciphertext, and then it becomes it needs to be deciphered through plain text again, but you will need the decryption key from the receiver. So here is the algorithm for RSA. So first you have two prime numbers, prime 1 and prime 2. So you have to select any of them. In my code, I use prime 1 and prime 2 as the variable, but at the same time, I use small numbers to show you how the algorithm works and how it can be implemented. So then you would find the modulus of both keys with n equals prime 1 times prime 2. Then you would calculate the totient, or Euler's totient, which is the number of positive integers that are relatively prime. One is counted as relatively prime in that sense. So then you would do prime 1 minus 1 times prime 2 minus 1, but you would first do those two. And then the next one you choose encryption, that encrypt is greater than 1, and coprime to totient, which means the GCD to encrypt totient encrypt totient must be equal to 1. Encrypt is a public key. Then you choose D such that it satisfies the equation DE equals 1 plus K totient, which is D is the private key not known to everyone. And then ciphertext is calculated by using the equation C equals M to the power of encrypt mod N, where M is the message. And then lastly, you would have the help of C and D to decrypt messages using the equation M equals C to the power of D mod N, where D is the private key. And then here is a little bit of snippets of my code. So you first find the greatest common divisor. Then you would do pick two random prime numbers, public and private key. Then you would choose choosing the decrypt, so you would have a decrypt number, and this would be the output. If you wanted to run the code itself, it's on the GitHub, and also it's pretty simple. If you just go over the code, I have some notes in there to show you exactly what each function is doing and where we're doing the calculations and everything like that. So from the output, you can see that the original message was 12, and then once it's encrypted, you would see that it's only 3, but once you decrypt it, it would show you that the original message was 12. Thank you so much for listening to my presentation. If you have any questions, please let me know. I will be posting up the code and also this PowerPoint in the GitHub folder under my name. Thank you so much.